All right, ladies and gentlemen, we're down to our last set of notes for Unit 3B with our congruency and our congruent triangles. We need to remember the definition of congruent triangles, the congruent triangles that are going to have the same shape and size. Okay, congruent, same shape, same size. We get this fun term called CPCTC. It's very, very fun listening to people try to say that for the first time. CPCTC. Each letter is going to represent a word, letting us know what we're going to talk about now. And what this is, CPCTC, stands for corresponding parts of congruent triangles are congruent. Okay? Pause it and get that written down because I'm moving on. So we have CPCTC. Corresponding parts of congruent triangles are congruent. And I know that I have drilled over and over and over again what the word corresponding means in my classes. We need to remember corresponding means matching. So the matching parts of triangles, if they're congruent, then all matching parts are going to be congruent as well. So we talk about congruency statement. I have brought this up with my students in my classes. We've got to know what a congruency statement is. All this is, we're just letting us know that when triangles are congruent, we write a congruency statement saying triangle this is congruent to triangle that. Now, we have to match our parts here, okay? And what you're going to notice is when we name these triangles, this is going to be very, very important. We have to name them in a particular order. The first triangle doesn't matter how we name it. It doesn't matter what order we put those letters in. But the second one, we have to match the letters with the corresponding parts of the first one. What that means is, here, we said triangle ABC. Angle A, right here, we see has only one arc. So we have to match it with the same angle over here that has one arc. And that would be angle D. So those two match, so therefore they are corresponding. And if A is mentioned first, the corresponding part D needs to be mentioned first. Then we have B, which we look down here and we see two arcs. So it's going to match with, let me make it a little bit smaller, sorry. We're going to match that with the two arcs on the other triangle, E. So that's why B and E are both in the middle. And then the last one is going to be, all right guys, I had a student come by and visit me. I had to pause that real quick. So then again, here we have our last letter C, and we're noticing that C has these three arcs, and it's going to correspond and match with the three arcs on the other triangle F, and that's why they're all going to be in that same order. This is why I like to use the color so that we can see what's matching exactly. So we talk about your corresponding sides. I kind of already gave you that the angles part of it, which we'll talk about again in a second. But here, our corresponding sides are going to be sides that match in the same place. Okay? So here, if we take, I'm going to write something else out here so we can actually look at, I'm going to rewrite the name. So here, I'm going to squeeze in triangle ABC is congruent to triangle DEF. And there's a reason I'm doing this, and I suggest you use colors and do this as well. What we're going to notice here is the first two letters right here, AB, is going to represent a segment, segment AB, and that's going to be these first two letters right here. So we're going A to B, so we have to go to the next triangle over here, the next name, and we have to choose the first two letters as well. So AB will correspond and match with DE, segment DE, and that's why we have that here. Now you cannot say segment ED, you cannot switch that around because D comes first, then E. A comes first, then B, so you have to keep that order consistent. The next one we have here is our segment. All right, let's take a look at the last two letters, BC. BC will correspond or match with the last two letters in the second name, EF. Again, we have to keep them in the same order. If we say CB, if we switch these, we got to switch these. But here we have segment BC is congruent to segment EF. And then the last one here, and this is where I kind of do like a little arc. We're going to take the first and the last letter, AC, and it's going to correspond with the first and last letter of the second triangle, DF. So here, technically, what they did was they went CA and FD, and that's perfectly fine. But as long as we're not going AC and then FD the other way, we can't do that, okay? So here they decided to say CA, so the last to the first, is congruent to FD, last to the first, all right? So that's how we name our corresponding sides. I know I told my classes that there is a particular order, and we talk about it in these notes. Now we're talking about our corresponding angles. We're going to have angles that match in the same place. My students, you're starting to understand why I've been saying matching every single time when I'm saying corresponding. We're matching the same place. So again, I'm going to go ahead and write down here, triangle ABC is congruent to triangle DEF. And we're going to see here that same thing we saw at the very, very top up here. We're going to see that the first letter of the first triangle goes with the first letter of the second triangle. So we have angle A and angle D will go together. The second letter or middle letter in the first triangle will go with the middle letter in the second triangle. So angle B and angle E will go together. And then lastly, we have the last letter corresponds and matches with the last letter. So angle C and angle F go together. Okay, so this is how you can find your corresponding parts. Look at the name of the triangle. Okay? So now let's talk a little bit more. We're going to talk about here, we'll fill in some blanks. Figures are congruent. If you want to listen first and then pause it and write it in, you may want to. Figures are congruent if they have the same shape, same size and shape. We already talked about it, that, okay? Also, their corresponding sides and their corresponding angles must be congruent. Again, pause it because I'm going to move on. Make sure you have this written down so you can listen to what I'm about to say. This is why we have these congruency statements up here, because the corresponding or matching parts, the first with the first, they're congruent. Your corresponding sides and corresponding angles have to be congruent for these two triangles to be congruent themselves. So let's take a look at identifying some things here. The first thing, looks like I have an older version of this before we have this all. It's all right. I'll make this work. Here we're going to find out segment BC, and you'll see why this is a little bit messy. I had to go edit it. Segment BC is congruent. Remember, segments and angles are congruent. Measurements, number values are going to be equal. So here we have segment BC is congruent to what segment on the other triangle? Okay, well, let's go figure this out, guys. We have segment BC. Let's find those two letters. BC are the last two letters in that triangle's name, so it's going to correspond and match the last two letters of the second triangle. So BC right here will correspond with segment EF right here. So here we'll have segment EF. Next we take a look at angle F is congruent to, well, angle F is the last letter. F is the last letter, so it's going to correspond and match with the last letter in the other triangle. So angle F right here will correspond with angle C. Therefore, they will be congruent. Next, we have angle A is congruent to, well, A is the first letter, so A will correspond, therefore be congruent with the first letter in the other triangle. So A right here will be congruent with angle D. So here our answer would be angle D. Now, we have an M in front, so that means measurement of angle E. So what we need to do is, yours should already be okay, but I'm going to white that out because measurements are equal, not congruent. So we want the measurement of angle E. All right, so how are we going to figure this out? I'm going to show you. Angle E right here, we're going to see that angle E is in the middle, okay? So it's going to correspond and be congruent with angle B. So I already have one arc, two arcs, so angle E, 3 arcs, will be congruent with angle B. They're both in the middle, so angle B. And we see that angle B is 77 degrees, therefore, angle E, its congruent corresponding angle, will also be 77 degrees. That's how that works. On this one, we're going to, yours should be fine. Let me write this out real quick. We're going to have DF. Now, we don't have that segment bar anymore because I erased mine. No segment bar, no congruent. So we're looking for an actual measurement here. So we take a look at DF, okay, segment DF. We're going to see that segment DF are the outer 2 letters here. So segment DF is going to correspond and be congruent with the outer 2 letters of the other triangle, AC. So DF over here, I already have 1 tick mark, so I'm going to put 2, is going to correspond with AC. And when they correspond, they're going to be congruent. So since AC is 5 centimeters, DF will also be 5 centimeters. Just finding their match, finding their partner. So now we're looking at triangle ACB is congruent to, we need to write in another triangle statement here. So we're going to have to match up our letters. So we're going to put our triangle symbol. A matches with D, so we put D first. If you rearrange the first letters, the first triangle's letters, you have to rearrange the second to match. C is the next letter in this triangle, so we need to go find C corresponds and matches with F. And then B. B corresponds and matches with E. Okay, so that's how we're going to work those problems through and figure out where our corresponding parts are. On the next page, we're going to go ahead and solve some stuff. We have triangle LMN is congruent to triangle JKL. We have that the measurement of angle M is 5x minus 7. The measurement of angle L is x minus 14. The measurement of angle K is 2x plus 17. So let's figure out what's going on here. First of all, we need to say, what are we trying to find? We want the measurement of angle K. So what we need to do is over here, when we find x, we're going to substitute in right here. So since I want a measurement of angle K, I can just look up in the names and I can say, okay, angle K is that middle letter. It's going to correspond and be congruent to the middle letter of the other one. So we're going to be looking at angle K and angle M. So angle L is just a little bit of extra information we don't need. So since angle K and angle M are congruent, their measurements are equal. So all we need to do is just set these two equal together. So we'll say angle M is congruent to angle K. Therefore, the measurement of angle M is equal to the measurement of angle K, meaning just set them equal to each other. So the measurement of angle M was 5x minus 7. We set that equal to the measurement of angle K, 2x plus 17. Please pause it. I always say this in the video, pause it, work through it, resume, and make sure that you did get the correct answer. Okay? Now that you have done that, I want you to check your work with mine. Okay? And if you did not get 8 for X, I need you to go step by step. I always use my different colors and figure out, whoops-a-daisy, where did we make our little small mistake that we won't make again. Okay? So now we wanted to find the measurement of angle K, so we have to substitute in. The measurement of angle K was equal to that 2x plus 17. So we're going to substitute in that x. I was telling my students, you don't have to draw the arrow if you don't want to, but that's for students who are still struggling with substitution. 2 times 8 will give me 16 plus 17. And the measurement of angle K will come out to a total of 33 degrees. And you can always plug that into measurement of angle M as well. Since they're congruent, they should both come out to 33. And now will, because 5 times this 8 is 30. Sorry, is 40, I'm going to get my math right, minus 7 gives you that 33. So you can always double check with the congruent parts to see, did I even solve for x correctly? Next, with your angles is a little bit easier. I'm going to show you something else here. Now that we are looking at segments, I'm going to draw these triangles out. You could always draw these triangles out. I'm going to draw in triangle ABC. Okay, here's A, B, C, and triangle DEF. These are really nice triangles, right? Segment BC right here, okay, is going to be 2x plus 3. Segment EF right here is going to be 4x minus 7. And when I look in my name here, I'm going to notice the segment BC corresponds with segment EF, meaning they are congruent. So we're going to set these together. So here we go, we have those. So since segment BC is congruent to segment EF, we could say therefore the length or measurement of BC is equal to the length or measurement of EF. So we'll go ahead and substitute in. BC was 2x plus 3. We set that equal to the measurement EF, which was 4x minus 7. You saw what I did solving for x in the last one. You're on your own. Please push pause now. Now that you got to pause. All right, so you should have 5. If not, please double check your work with mine and see what may have happened. Okay. Now, they did want us to find the measurement, well, it shouldn't have, that one I did not catch before I did this. It should not have that segment bar above it. It should just say BC, because we're looking for the measurement of BC. So we're going to be plugging that into BC is 2x plus 3. And in reality, since they're both congruent, it doesn't matter. Plug the x into both of them and see if they come out the same. If not, we made a mistake with solving for x. Okay? So here we'll go ahead and say, all right, BC was that 2x plus 3. We're going to remove x, and we're going to substitute in x was 5. 2 times 5 is going to give me 10 plus 3. BC will equal a total of 13. And again, if you plug it into the other one, you have 4 times 5 gives you 20. Subtract 7 from 20, you're going to get that 13. So this is how we're going to use our corresponding parts of congruent triangles to find different side measurements and angle measurements.